Today we are going to learn how to represent or store trees in computers. So suppose we have this tree, or we can say complete binary tree. So you can say 1, 2, 3, 4, 5, 6 and 7. So how we are going to store this in computer? Let's see. This is tag, we can say. So first node is A, so we will write here A. So we can say A is parent and B and C are child. So after A, what will come? B first left, then C right child. So we can say 1, 2, 3. So A's children are B and C. The B is left one and C is right one. So now B's children are D and E. So first after C, what we will write? We will write D and E. B's children are D and E. So first left one, then right one. So B is the left child of A. So first B children will come and B is first left, then right. So we will write first D, then E. So B's children are D and E. Now C children will come. What are C children? F and G. So first left, then right. So F and G. These are C's children, 6 and 7. So in that way we store the tree in the computer. And we can say simply, if any node is stored in, or we can say at ith place of the array, then parent of I is equal to I by 2 position, and the second one, or we can say the left child of ith node is equal to 2 into I, and the right child of I is equal to 2 into I plus 1 position. 2 into I plus 1 position. So we can say simply the bth is, the left child is on 4th position, so parent will be on 2nd position. So 2 into I, 4th position, and this is on the 2nd position. And the right child of B is 2 into I plus 1. It means 2 into I, 2 into 2, 4 plus 1, 5th position. So this is the logic of it. So now I'll take another example. Suppose we have this kind of array. This is complete binary tree. As we know, it is having all left and right children. So this is complete binary tree. Now we talk about the binary tree. A, B, C, D and E. Suppose we have this, or this is, we know this is binary tree. So 1, 2, 3, and this is 1, 2, 3. Now 4, 5 B's children are not available, so we will leave it. So it will be 6 and 7. How? Let's see it. Let's see here. So first start with A. So A is the parent, and after that what will come? A's childs are B and C. So B is left, so first B will come, right, C is right child, then C will come. So 1, 2 and 3. Now we can see simply from here B's children are not available, so we will leave the space for left child and for right child. We'll leave the space. Then after that C's children will come. So C's children are D and E. So we will write here D, first left then right. So 1, 2, 3, 4, 5 we will left here because children are not available of B, and C children are available, so we will write 6 and 7 here. So in that way we can store the binary tree in the computer. So because static data structure, because we are storing in the array, we are storing the tree in the array, and array is static data structure. So we have to maintain null. We have to maintain null. These are the values of B, or we can say the B's children. We have to maintain null because we are storing in the array. So if required, so that we can link them later. But if we store in linked list, then no need to maintain null position. So this is the way how we can store trees in computer.